Okay, so we're going to go over identifying conic sections. So you're going to have all the conic sections mixed in together, and you're going to have to identify what kind it is. And part of the assignment is to graph, part of it is just to identify what it is. So I'm going to tell you what to look for. Okay, so for a parabola, is only going to have one squared variable, where all the other ones are going to have two squared variables. So for example, on your sheet, number 3 is going to be a parabola because the x is the only variable that's squared. Okay, can you guys see any other parabolas? Number 9.
Number 9.
And 6. That's right. Those are the other two. Okay, so then we have circles. And for circles, you'll have two squared variables that are the same sign. So that means they're both going to be positive or both of them negative, but in the end, when you put it in standard form, you want them to ultimately both be positive, right? Okay, so they're both the same sign, and they have the same coefficient. So if one squared variable has a 3 for a coefficient, the other squared variable needs to have a 3. So in your examples, like number 1 is going to be a circle. Can you see any others that are circles? 4 and 12. Right. Okay, then the next conic section that we have gone over is the ellipse. And for an ellipse, you'll have two squared variables that have the same sign but different coefficients. They cannot have the same coefficients. So, for example, number 2 is going to be an ellipse. Can you guys see any other ones? 8 and 10. Right. Okay, and then our last type of conic section was a hyperbola. A hyperbola will have two squared variables that have opposite signs. So it's going to be a subtraction problem. They can have the same coefficient. A hyperbola can do that, but it has to have opposite signs. One's a positive, one's a negative. So, for example, on your sheet, number 5 is going to be a hyperbola. Do you see any other hyperbolas? 7 and 11, right. That's right. Okay, so let's do an example. Let's do number 11 for an example. We're going to write this in standard form and then graph it. Okay, so we know this is going to be a hyperbola because the x squared and the y squared have opposite signs. And so when I rearrange all of my variables, I want to put my y's together and my x's together. I'm going to write the x values second because that's going to be the negative value. And then I'm going to move this 5 over to the other side. So I'm going to start out with the y's. 2y squared plus 20y minus 3x squared minus 18x equals negative 5. And I need to complete the square to get this in standard form. So I need to factor a 2 out of my y, so I have a leading coefficient of positive 1. 2 times y squared plus 10y. I'm going to leave some space so that I can complete the square in the parentheses. And for my x's, I need to factor a negative 3 out, so I have a positive 1 coefficient for my x squared. That's going to change my linear term to positive. And I'll have x squared plus 6x equals negative 5. Okay, so for my y's, when I complete the square, I'm going to add 25 in the parentheses. What am I going to add to the opposite side? 50. For my x's, I'm going to add 9. What am I going to add on the opposite side? Negative 27. Okay, so now I can factor. And I add my constants together. I think that's going to be 18. So the last thing I need to do is divide everything by 18, and I'll have it equal to 1, have it in standard form. Y plus 5 squared over 9 minus x plus 3 squared over 6 equals 1. Now I can find my center. And remember, your h is with the x value. So for your center, h is negative 3 and k is negative 5. And the slope for my asymptotes is going to be plus or minus 3 over radical 6. So I need to rationalize that. That means I need to multiply top and bottom by the square root of 6. So I don't have that radical in the denominator anymore. So I have 3 radical 6 over 6, and I can simplify that down to plus or minus radical 6 over 2. That's my slope. Okay, so let's graph this. You guys are going to need to use graph paper on your assignment. Okay, I'm going to graph the center first. Negative 3, negative 5. Right there, that's the center. And from the center, I'm going to count the slope. Now, radical 6 is about 2.5. That's rounded, roughly. So I'm going to count my positive slope first. I'm going to go up 2.5, and then over 2, down 2.5, and over 2 to the left. I have my first asymptote. I'm just going to draw the dotted line. And once you get that first line going, then it's easy to get your slope for the other line because they're really reflections of each other. One's on top and the other one's on bottom. It makes a little box. There's my other asymptote. Okay, so which way is this going to open since y is positive? Vertical. Yeah, your y-axis is vertical, so since y is positive, it's going to open vertically. My A is 3. That means that the vertex is 3 units away from the center. So I don't need to even really find the vertices. I can just count from my center, count straight up 3 units. There's one vertex. Straight down 3 units. There's my other vertex. And then just use the asymptotes to draw the shape and that's going to be your graph. Don't make it really hard, okay?